Welcome to Algebra 1 with Miss Betsy. Today we're going to continue our discussion of working with quadratic equations by learning how to complete the square. And this lecture is going to be based off of the second edition of Algebra 1 for Christian Schools, published by Bob Jones University Press. Again, it doesn't matter what text you're using. This lecture will teach you how to complete the square when you're trying to solve quadratics. Before we get started, let's go ahead and pray. Then we're going to see this lame joke and see what we can learn about completing the square. Father, I thank you that you are always present with us. I thank you that you walk side by side with us and that you love us as much as you do. Lord, I ask that you would help us to learn the things that are placed before us today, help my viewers to comprehend the material well, help me to communicate clearly, and I pray in Jesus' name, amen. Okay, can't remember if I've used this one before, but there are actually two, and these are truly awful questions. Where does the lizard keep his groceries? In the refrigerator. As in the alligator, I guess an alligator and a lizard are together. This is this book that one of my students gave me, and I sometimes think the jokes were taken from 5-year-old children. What do you get when you cross a dog with a cell phone? You get a golden receiver. So, let's go ahead and see what we can do about learning how to complete the square. If you're using the same text I am, we're in section 11.4 on page 456. Looking for my markers. See if I can find my brown one. Guess I don't need a brown one. So far we have learned two ways that we can find the solution to quadratic equations. We can factor them, and where we have the quadratic set equal to 0, factor them and use our zero product property to come up with the solutions to that equation. We've also learned that we can take the square root of both sides of the equations at very specific times, to solve a quadratic. But we're also going to see, here's my brown marker, we're also going to see that a lot of the time there are going to be quadratic equations that you simply cannot factor. For example, if we have something that looks like this, a squared minus 7a minus 3 is equal to 0, and you think, okay, I have everything set equal to 0. This equation is in the standard form for a quadratic, but I can't factor that because the only factors of 3 are 3 and 1, and there's no way that they're going to add up to 7. Well, let's go ahead and put the squared term on the left side of the equation, the remaining terms on the right-hand side of the equation, and we can't take the square root now of both sides of this equation to solve it because we have a variable on the right-hand side of the equation. So, what we're going to do, I'm going to change this problem out because we're going to look at this one a little bit later, but what we are going to do is we're going to take the square root of both sides of the equation after we force what is on the left-hand side of the equation to become a perfect square trinomial. This right here, let me see what I want to do. This right here is a perfect square trinomial. You already know how to recognize the difference of two squares, and you were able to factor something that looked like 4x squared minus 49. Both the first term and the last term are perfect squares. So since this is the difference of two squares, you should be able to immediately factor 4x squared minus 49 as 2x plus 7 times 2x minus 7. And then you also learned to factor perfect square trinomials. So it's a trinomial and it's a perfect square, and you recognize perfect square trinomials because they have a particular pattern that they follow. With perfect square trinomials, the coefficient of the middle term, or the coefficient of the first degree term, is twice the product of the square roots of the coefficient of the x squared term and the constant term. Square root of x squared, that coefficient is 1. Square root of 4 is 2. 1 times 2 is 2. Twice that product, or twice that 2, gives us 4, which is the coefficient of the first degree term, and that's how we identify that's how we identify perfect square trinomials. So this, you've learned, has two identical factors, and this would factor as x plus 2 squared. If this were x squared minus 4x plus 4, works the same way, except it's x minus 2 squared. So a brief reminder of what perfect square trinomials are. You have to know how to factor them, because you're going to use how you factor a perfect square trinomial to complete the square. Now let me go ahead and show you exactly what I mean. How we're going to do this. Let's say that we have a binomial, or a two-term polynomial. We have x squared plus 10x, and we want to be able to make this into a perfect square trinomial. Remember, I just erased x squared plus 4x plus 4 and said that you recognize that this is a perfect square trinomial because this coefficient here, 4, is twice the product of the square root of 1 times the square root of 4. 1 times 2 is 2. You double that, and you have this coefficient here of 4. Well, you can force a binomial to become a perfect square trinomial by sort of reversing the process to come up with your constant term. What are you going to do? What you're going to do is you're going to divide the absolute value of this by 2, and then you're going to square that result. What is 10 divided by 2? Going to take technically the absolute value of this coefficient. This coefficient here is a positive 10, so the absolute value of 10 is 10. Now we're going to divide that by 2. When we divide 10 by 2, we get 5. Now we square the result. 5 squared is equal to 25. This is the constant term that we're going to add onto this existing binomial, and this then is now a perfect square trinomial. Let's go ahead and look at this. How do we know it's a perfect square trinomial? This coefficient here of the x term, 10, has to be twice the product of the square root of this coefficient and the square root of 25. So it has to be twice the product of the square root of this coefficient times the square root of the constant term. 2 times 1 times 5, of course, is equal to 10. So this trinomial here is a perfect square trinomial. How did we know that we had to add 25? We worked the process in reverse. We took the absolute value of this coefficient, which was 10. We divided it in half, which gave us 5. 10 divided by 2 is 5. We squared that, and we ended up with 25. So that's how we can go backdoor into what this constant term is. Now that we have a perfect square trinomial, we can factor this because you have learned how to factor perfect square trinomials. My kids, if you haven't learned how to factor perfect square trinomials, or if perchance you forget how to, learn it, period. I wish I could make it easy, but you have to recognize them, you have to know how to factor them. Not remembering what section it's in, it's probably chapter 9, maybe section 7. Let me see if I can pull it up right now. Trinomials of different forms. Factoring perfect square trinomials is section 9.3. If you've forgotten how to do it, go back and do a refresher, or else you're not going to be able to complete the square. This will factor then into x plus 5 quantity squared. We've created a perfect square trinomial. Because it's a perfect square trinomial, we can now factor it. So example 1 here says complete the square and then factor it. We have a squared minus 16a. This is example 1. How do we complete the square when we have a second degree term and a first degree term? We're going to take the absolute value of this coefficient. What is the absolute value of a negative 16? The absolute value of negative 16 is 16. Now we're going to divide 16 in half. 16 divided by 2 is 8. We take that quotient, the answer when we divide it by 2, and we square it. 8 squared is 64. We are going to add this product to the binomial, plus 64. Okay? This is how we complete the square. What do we do first? Take some notes. In step 1, we take the absolute value of the coefficient of the first degree term. The middle term in our trinomial. We're going to take the absolute value of it. It will always be positive, won't it? Because absolute value is distance. Distance is never negative. Once we take the absolute value, then what do? We divide that by 2. What do we next? What do we do next? We square the result. 8 squared is 64. What do we do with that? We add this to whatever expression you are working with. This is how you complete the square. Learn the pattern and you'll not have difficulty with these problems. Sometimes the algebra or sometimes the arithmetic might get a little bit messy, but you're not going to have any difficulty doing the problems. We now have completed the square. We have a perfect square trinomial, and it's time to factor it. How do you factor it? You recognize it's perfect square because this is twice the product of the square roots. Square root of 64 is 8, times 1 is 8, doubled is 16. Because you have a negative second term, when you factor this, it is a minus 8 quantity squared. All right? Let's see what I want to do next. Let me do one more quick example. Just showing you how we complete the square. Say that we have this expression, x squared minus 5x. And we want to complete the square. How do we do this? We're going to take half the absolute value of the coefficient, divide it in 2, square that result. And you say, but we can't do that because that's going to be negative 5 halves the absolute value. Wait a minute. Going to take the absolute value of negative 5, which is 5. Then we divide it in half, and we've got 5 halves, and now you're saying we have to square that? Yes, you square 5 halves. How do you square a fraction? When you square a fraction or a rational expression, both the numerator and the denominator are squared. So we end up with 25 over 4, and that's exactly what it's supposed to be. We're going to add 25 over 4 to our expression. Now, if we wish to be able to go ahead and complete that square, the sign of our binomial, sign of our term of our factor term is going to be negative. It is x minus this number divided by 2, x minus 5 halves. Quantity squared. Really works. You can go back and check that either by remembering how to square a binomial or go ahead and FOIL it if you need to. Just in case you're not convinced and you don't remember how to multiply this. When we FOIL, first terms together, x squared. Outer terms, minus 5 halves x. Inner terms, minus 5 halves x. Last terms, negative 5 halves times negative 5 halves is plus 25 fourths. Negative 5 halves plus negative 5 halves, negative 10 halves, which is negative 5. X squared minus 5x plus 25 fourths. Which you see is exactly the expression that we ended up with when we were completing the square. So trust your work. Don't get freaked out when you see that the things look really weird and you think, oh, it's got to be wrong, it's got this really bizarre looking fraction. Well, a lot of the time the really bizarre looking fractions are exactly what you're looking for. Alright, let's move on. Okay, one more example with a fraction. This is example 2. X squared minus 3/5 x. Complete the square and then factor it. X squared minus 3/5 x. What do we have to do? We're going to take half the absolute value of this coefficient. So what is the absolute value of negative 3/5? It's 3/5. How are we going to take half of that? Well, 1/2 of means 1/2 times 3/5, and we end up with 3/10. Half of 3/5 is 3/10. What do we do now? We square that product. 3/10 times 3/10 is 9/100. 9 over 100. We add that quantity to our existing expression. We now have a perfect square trinomial, and we factor it by saying x minus 3/10, quantity squared. That's the factored form of this perfect square trinomial. X squared minus 3/10 x doubled is minus 6/10 x. Minus 6/10 reduces to minus 3/5, doesn't it? And then you have negative 3/10 times negative 3/10 is positive 9/10. Trust the formula. Trust the process that you're using to complete the square. Next problem. Now that we know how to complete the square, we're going to use this method of completing the square to solve equations. If you have x plus 7 is equal to 16, way back when this material was new to you, and we learned that we could subtract the 7 to make the x go away, sometimes you would end up with this incorrect expression. We did isolate the x variable, but like we wanted to, but we didn't keep the equation in balance. We subtracted 7 from the left side of the equation, so we needed to have subtracted 7 from the right-hand side of the equation as well, which then, of course, would have given us the correct answer to this very easy equation here, where x has a value of 9. You have to remember to do that when you're using the process of completing the square to solve quadratics. So we have x squared plus 8x is equal to 9. Now we're not trying to factor this by moving the 9 to the left-hand side, and I'm going to show you in a moment how we can do that by factoring. But we are not going to solve this equation right now by factoring. We're going to use the process of completing the square. When you complete the square, you have the x squared, you have the x to the first degree. X squared plus 8x. And what is it that we do? We take half this coefficient, half of this absolute value. 8 divided by 2 is 4. And we square it, and we add that to the expression. X squared plus 8x plus 16, that's now a perfect square trinomial. But this isn't all we're doing. We're solving an equation. So we have to continue writing that entire equation. X squared plus 8x plus 16 is equal to 9. Are we finished? No. We have to keep our equation in balance. We've added 16 to the left-hand side of the equation. So we need to add 16 to the right-hand side of the equation as well. We now have x squared plus 8x plus 16 is equal to 25. We have a perfect square trinomial. This coefficient is twice the product of the square roots. 2 times 4 is 8. We factor this. We have x plus 4 quantity squared is equal to 25. Squares, perfect squares on both sides of the equation. And now you can go ahead and take the square root of the left and the right hand side of the equation. So we're going to take the square root of x plus 4 quantity squared, and it's plus or minus the square root, remember? Plus or minus the square root. What do we have? Square root of x plus 4 quantity squared is x plus 4 is equal to plus or minus 5. We're going to subtract 4 from both sides of the equation. We have x is equal to negative 4 plus or minus 5. So x can be equal to a positive 1 or a negative 5. And I just got a note from my friend telling me we're running very, very short on time here. This is how we use the process of completing the square. Okay? You could have actually factored this one. X squared plus 8x minus 9 is equal to 0 by saying x plus 9 times x minus 1 is equal to 0. And of course you would have ended up with x is equal to 1 or x is equal to a negative 9. But we're using this to show you how to use the process of completing the square. So I'm going to go ahead and say this is the end of part 1 of 11.4, and I'll come back later and finish the rest.